Okay, I wanted to show you how to do solving systems on your calculator. So yours in class are pretty much the same, it's slightly different. I forgot to bring one home with me, so this will have to suffice. So the first thing, here's our first equation. Notice both of these are linear. I know they're linear because they have the highest power is next to the first power. So this is a system of lines, so two lines are only going to intersect at one point, so I should be expecting one intersection. So if I go into y equals, I'm going to clear out what I have here, as should you. Now if your calculator ever has one of these, are called your stat plots highlighted, it could potentially make it so that it doesn't graph properly, so you can go up and you can hit enter on it and it will deselect it. Okay, so I'm going to put in 3. Remember that your x is diagonally down from the second button. So 3x subtract 5, and then on your calculator also remember that the subtract and the negative are two different things. In real life they do the same function, but in your calculator there's two different things. So I would use the negative when I have a negative in front of, for the leading coefficient, instead of if I'm subtracting I would use a subtract sign. So for example, the negative 1/2, here's when I would use the negative 1/2, and you can put this in parentheses to get the negative 1/2, and then times by the x. Then if I hit graph, mine's set to go to the standard window. If you look at your window, this tells you how far left I'm going to go, this tells you how far right I'm going to go. This tells you the scale, so what this interprets to is this goes left to 10, right to 10, and each one of these tick marks is 1. So if I go back to my window, notice that the y's are the same. The y min is how far down it goes, the y max is how far up it goes, and the y scale is by how many per tick mark. So this goes from negative 10 all the way to positive 10, and each tick mark represents 1. So if I were to represent the tick marks with a 2, notice my x scale changes, and that each one of these is now representing 2. Each tick mark is representing 2. So there's 2, 4, 6, 8, 10. Okay. So that's your basic of your window. If you go to zoom, you have all these different options. Zoom standard is the one that moves it from negative 10 to 10 on your x and your y and does a scale of 1. So notice these lines intersect. So just like your flashcards say, you're going to do second. And then trace is the button, but above it, it has the yellow, I think yours is in blue at school instead of yellow, but whatever color the second button is, the one that matches it, the calc will say that. So second calc, we're looking for the intersection, so I want number 5. Now it's talking about the first curve. It says curve because it doesn't know if the equation you put in there is a line or a curve. You know that because you put it in there, and that it is a line. So first curve, yes, that's the one that I want. I hit enter. Then my second curve, yes, that's the one that I want. I only have 2 equations, so if you have 2 equations, it's really just as simple as doing enter, enter, enter. And then that gives me the intersection. So then I would write the point negative 1.4286, comma, negative 0.7143. You can round to 2 or 3. I rounded to 4 that time, but 2 or 3 decimals will suffice. Okay, the next one is also a system of lines. So I'm going to go here, clear out both of these. Okay, so I'm going to do 7/3 x, subtract 4, and negative, notice I'm using the negative 2/3. And we want this in parentheses. If you forget to do parentheses, you can do second insert and then do a parenthesis. Then it won't write over it. It's just like the write over function in like Microsoft Word. Negative 2/3 x plus 1. So I hit graph. Notice the intersection is in the window that we have, so I'm going to hit second. Calc or trace. I want the intersection. Now you can scroll down to number 5, or you can actually hit 5. And then if you have more than 2 equations in your calculator, you can go between the equations by hitting up and down. If you want to move left and right on your or move across the screen, you use the left and right. To switch between the lines, it goes up and down. Notice up here that I can tell which equation I'm on because it says y2 equals, and then it gives me the equation. Right, so it says first curve, second curve, enter. And it doesn't really matter what's the first curve and what's the second curve. So then I would write this in point format as 1.67 negative 0.11. So for 3, now we switch. This is something that you would have learned in secondary 2, I believe. So now we switch back and we are looking at what we are learning this year. This is a polynomial. I know that because it's a third power, right? None of the powers are negative. There's no variables in the denominator. And all the coefficients are real numbers. Same with x to the 4th plus 2x squared minus 7. So both of these are polynomials, so I'm going to see where the polynomials intersect. So I have x to the 3rd power, and on your calculators you have to hit over because it will write the degree up above. So make sure you hit over after x to the 3rd minus 4x squared. I like to, rather than do caret and then 2, I like to just use the x squared button. Plus 5x minus 6, and then I have x to the 4th, and again you're going to have to hit to the right for the calculators that are in class, plus 2x squared minus 7. I'm going to hit graph. So there's what y1 is, which is r cubed, and there's to the 4th power, which is y2. So I'm going to hit second calc, number 5. Now I have 2 intersections on this one. When you have more than one intersection, you're going to have to do this process more than once, one for each intersection. So I have to move the cursor towards which intersection I want. So let's just pretend momentarily that I want that intersection first. So I'm going to move my cursor towards that intersection. So I can hit to the right. If you want your cursor to jump quickly, you can hit second and then over, and it will jump quicker. Or more, so then it's quicker. So that's my first curve, second curve, I'm gonna guess, or hit enter for guessing, we don't really actually guess. So my intersection is 1, negative 4. Okay, then I have to do it again for the second intersection, so second calc, still want the intersection. This time I want to scroll over to this intersection. So I just want to get closer to that one so the calculator knows that's the one of interest that I'm looking at. So I hit enter, enter, enter. So I get negative 0.166 and negative 6.944. If we look at number 4, so I'll just move the picture like that. Yeah, that works. This is where we had a polynomial and an absolute value. You've learned about absolute values before. So if we go here, now pretend that you were doing something and maybe you wanted those later. You can just go to the left and you can hit enter on the equal sign and it will deselect that, so I can come back to those later if I would like, and then I can put these two equations in y3 and y4. That's a scenario that you could have. So if I do that, I have x to the 3rd, remember to hit over after that, minus 4x squared minus 2. Remember that your absolute value is under math. We want to go to num, so these are like tabs, like on a browser. So I'm going to go to the tab of num for numbers, and then I want abs for absolute value. So I want the absolute value of x subtract 3. On yours, it will put the bars there for you, so you just need to make sure that you arrow over so you get out of the bars, so that your cursor is lying outside the bars. So your cursor should be right here on your calculator. And then I'm going to do subtract 6. Okay. Now notice when I graph these, that the last two equations that I had don't actually show up. Okay, which is the point of deselecting it on the equal sign, so that you don't have to retype anything if you're using it again later on. So this one has 3 intersections, so I'm going to do this process 3 times. So second calc, number 5, let's go from left to right. So here I'm going to do enter, enter, enter. So I get negative 0.377, comma, negative 2.62. And I'm going to do second calc. I want number 5. Enter, enter, enter. And I get 0.726, comma, negative 3.73. Now, you know that you've hit enter enough times if you get lost in your hitting enter plan. Notice that it tells me the intersection. When we do this next one, it says first curve, second curve, guess, and then it will say intersection. So if you can't remember what you've done, it lets you know right here where you're at in those steps. So I'm going to do second calc. I want the intersection. So I'm going to go over. So now you can see that I'm on the polynomial, which means I have to go down here. I don't know how far down this goes, probably not super far down. But if you want, you can hit the up arrow and that will jump it to the absolute value, and I can move the absolute value along that one because it seems like a shorter distance. Okay. So now I'm close to this intersection here, so I hit enter, enter, enter. And the last point is 3.77, comma, negative 5.23. Okay. So our next one that we have, okay, if I go back to y equals, I'm going to clear out everything that I've got now. So I have 5, I have a polynomial, and this is a radical, so your polynomial intersected with a radical, which is one that we did more recently. I'm sorry. So I'm going to do 2x to the third minus 5x squared plus 2x subtract 3. And then 2, your radical is second, and then you have, let's move this up a little bit. Over. Okay, so I have 2, the square root is your second, and then x squared. Notice above that it has the square root sign, so I do square root of x, oops, I forgot my plus sign, plus 3. I have to close my parenthesis. You need to hit the arrow over button so that you get out of the radical. So your cursor will be right here, and then I do subtract 8. Okay, so I'm going to hit graph now. So notice I have 3 points of intersection here. I've got one there, there, and there. They're close together, but I still have 3 of them. So I do second calc, intersection, enter, enter, enter. So I get negative 0.407, comma, negative 4.78. And then I'm going to do it again. So I got my furthest left one. Now I'm going to go for the middle one. So second calc, number 5. Enter, enter, enter. I get a nice one of 1, negative 4. And I'm going to do second calc, intersect, so number 5. I only went down to 2, but I hit the button number 5, so it depends on what button you hit. So since I didn't hit enter, it didn't go to 0. So then I hit enter, enter, enter. And it tells me 1.89, negative 3.5. 7. Let's take a look at our last one. Okay, let's make sure that we show that. So this is the problem above. So this is a rational. I know it's rational because it's a fraction. Right? So I'm going to go back here. I'm going to clear out both of these. I want to make sure that I'm saying this entire top divided by this entire bottom, so I'm going to put parentheses. Remember on your calculator that you can do alpha y equals, and it has the option for the numerator and the denominator. This calculator does not have that option. So I can do 2x minus 5 divided by 3x plus 4. I double check, I look at my parentheses, this closes the top, that one closes the bottom, so I have top divided by bottom. So I'm okay there. So I'm going to put in negative x squared plus 12x subtract 32. So I'm going to hit graph. Okay. Now on the rationals, depending on your calculators, you will get this weird kind of line here sometimes, depending on what settings you have available on your calculator. This is called an asymptote. Okay, it's something, the graph gets super close to the asymptote. It doesn't actually touch the asymptote. This line is not actually part of the graph. This is your calculator trying to say, well, this point is right here, and then I have this point that's right down there, and they're really close in their x values, so it's drawing a line between those 2 points. It's connecting the dots. Okay, but this is not actually, this vertical line is not part of your graph. You've got this one right here, and then this one right here is the rational graph, the 2x minus 5 and the 3x plus 4. That's the rational graph with this unsaid asymptote that you'll learn about later on, how to graph them specifically. And then this is your parabola that you have. Okay, so it intersects at 2 places, so I'm going to do second calc. I want number 5. I'm going to scroll over, so I'm going to hit second over, because the cursor jumps faster, right? That was very small steps as opposed to that one is a much larger step. So I want this first left intersection, so I'm going to go enter on the first curve. Notice it tells you up here also which curve you're on, so I now know that I'm on Y2, so I hit enter, and then it says guess what your intersection is. I have no desire to guess, so I hit enter. So then your intersection is 4.05, 1.92. Okay, but I've got the second one, so I do second calc. I still want the intersection. I'm going to do second and over. It's close enough, so I hit enter, enter, enter. And I get 7.9, 0.3099. Okay. And that is how you find the intersections for line in line, polynomial, polynomial, polynomial absolute value, polynomial radical, rational, and polynomial. Basically any 2 graphs that you can put in here. Notice that when you are putting equations in here that they have to be set equal to y, so if you ever come across a scenario where it's not equal to y, you have to get it set equal to y first and solve for y and get that by itself, and then put it in your calculator.